Here we're going to look at another example that involves z-scores. Example 2 states the results of a certain medical test are normally distributed with a mean of 168.5 and a standard deviation of 12. Convert the given results into z-scores and then use the z-table to find the percentage of people with readings below 190.1, above 154.1, and between 154.1 and 90.1. So let's focus on part A. And even though a picture is not necessary, sometimes it's nice to visualize what's happening here. We have a mean of 168.5 and a standard deviation of 12. So what should happen, 168.5, that's a score, a test score of whatever this medical test is. Anything above 168.5 would be to the right. Any score below 168.5 would be to the left. Notice we aren't using the 68, 95, 99.7 rule here. We are given these scores that aren't necessarily 1, 2, or 3 standard deviations above or below the mean. They might be in between those values. So in part A, we're asked to find the percentage of people with readings below 190.1. So you can imagine, a score of 190.1 would be somewhere to the right there. We need to know how many standard deviations above the mean that is, and that's what a z-score tells us. So we need to find the z-score of 190.1. Z-scores are calculated by taking the data value minus the mean and then dividing that result by your standard deviation. So that subtraction up top gets us 21.6 divided by 12. So the z-score of 190.1 is 1.8. That means that this score is 1.8 standard deviations above the mean. So then what we do is we look at our z-table with the z-scores and percentiles. So you do need to have that table. The table value for z equals 1.8, when you look up the z-score of 1.8, you get a percentile of 96.41, and that's a percent. That table value is always telling you the percent of data below that score. And that's what's asked in part A. It says what percent of people have a reading below 190.1. So the 96.41% in this scenario is your result. It's your answer. For part B, they're asking, same situation, but they're asking for what percentage of people have readings above 154.1. So still with same mean and standard deviation. Again, the picture's not necessary, but it gives you an idea of what's happening. 154.1 is going to be below. It just gives you an idea of what to expect. It's going to be below the mean, so you would expect a negative z-score. Z-scores are negative when they are below the mean. So let's start by calculating the z-score for 154.1. It's the data minus the mean. The mean is the 168.5 divided by the standard deviation. This is negative 14.4 divided by 12, which is negative 1.2. So that's telling you the score of 154.1 is 1.2 standard deviations below the mean. If we look up our table value for z equals negative 1.2, we will get a table value of 11.51. So when z is negative 1.2, our table value is 11.51. Note what that is telling us. Again, it's always telling you below. So that number is telling me that 11.51% of the data is below that value. Notice we are asked in our question what percent is above that value. So since the entire curve is 100%, we're going to need to take 100% minus the 11.51% to get the desired result. So that would be 88.49% for being above the score of 154.1. And lastly, we're asked for the percent of scores between 154.1 and 190.1. We already know, we've already looked at these z-scores, so we're not going to recalculate them. The z-score for 190.1 was 1.8, which gave us a percentage of 96.41. The z-score for 154.1 was negative 1.2, which gave us the table value of 11.51%. So we have the 168.5. We had the 190.1 over to the right. We had the 154.1 to the left. And we're trying to figure out the percentage between those two values. What's here? We know that below the 190.1 is 96.41%. We found that out in part A. We know that below the 154.1 is 11.51%. And since we're trying to find this percent in between, notice on that last one, I didn't use the 88.49. I want to know what's below. I'm using that initial 11.51% that we found from the table. So between the two, we need to subtract the percentages. Notice you do need to find the percentages first and then subtract. Subtracting z values would not work. So find your two percentages, and then we're going to subtract 96.41 minus 11.51, which would tell us that between those two values, 84.9% of the people would have scores between those two values.